In this video, I'm going to talk about finding global or absolute maximum and minimum for a rational function. In our case, rational function is x squared over x squared plus 1, and in the interval -2 to +2. It's a closed interval. Now, by extreme value theorem, we see that f of x is continuous on this closed interval. Therefore, there must exist a global maximum and a global minimum for this function in this closed interval. Now, how do we go about finding those maximum and minimum values that are global max and global mins? There are two steps. The step number one is you evaluate the function at the boundary points. In our case, the boundary points are -2 and +2. So step one, we find the values of the function at f of -2 and f of +2 is going to be -2 whole square over -2 whole square plus 1, which is very easy, by the way, 4/5. Okay. Then we also find the value of the function at f of +2. So x equal to 2, and it is also going to be 4/5. So it's going to be 2 square over 2 square plus 1. That is going to be 4 divided by 5. So these are the two values that we will need to look at later. Step 2, we find the critical points. Of f of x. Where do I find it? In the open interval on -2 to +2. We find the critical points in the open interval. Now, the way you find the critical point is take the derivative of the function and set it equal to 0. So f prime of x, and we are going to set it equal to 0. So f of x, I can rewrite it as x squared times x squared plus 1 to the power -1, so that I can use the product rule. That's going to give me f prime of x is equal to, let's say this is my u and this is my v. U times derivative of v, so u is x squared times derivative of v is going to be, using the power rule, is going to be -1 times x squared plus 1 to the power -1 minus 1 is -2. And then using the chain rule, the derivative of x squared plus 1 is going to be just 2x. Plus v times derivative of u. V is x squared plus 1 to the power -1, and the derivative of u is 2x. And we set that equal to 0. Now let me just simplify the terms. I'm going to have -x squared times 2x in the numerator, and I'm going to bring down the x squared plus 1 to the denominator so that I can simplify it. Then plus 2x, okay, over x squared plus 1. All of it is equal to 0. Now, to make the common denominator, what I'm going to do, I'm going to multiply this by x squared plus 1 and divide it by x squared plus 1. That way I will have common denominator because this one has a square in it. So I'm going to have -x squared times 2x, right? Then plus 2x times x squared plus 1. All of it divided by x squared plus 1 whole square, and that's equal to 0. At this point, I'm going to simplify it further, pretty much -2x cubed, because these two, if I multiply, is going to give me -2x cubed plus 2x cubed plus 2x. I'm distributing the 2x to the numbers inside the parentheses, all of it divided by x squared plus 1 whole square is equal to 0. I can multiply both sides by x squared plus 1 whole square because it's a non-zero number, right? So that's going to give me 2x is equal to 0. That implies x is equal to 0. Look, this and this is going to cancel out, and I will have 2x in the numerator and this number in the denominator. So if I multiply both sides by x squared plus 1 whole square, then I will have 2x equal to 0. That implies x equal to 0. Now this is the critical point for this function. So what is the value of the function if f of x equal to 0, which is, by the way, 0 over 0 plus 1, which is just 0. So the function has a value of 0 at x equal to 0. So we have found three distinct points from both of these sets. One is this one associated with the boundary point, boundary point -2, and this one associated with boundary point +2, and this one associated with the critical point x equal to 0. Obviously, we can see that global / absolute minimum happens at x equal to 0 and f of 0 is equal to 0. And global / absolute maximum happens in two places, at x equal to -2 and f of x equal to 4 over 5. And then the other one is 2 and 4 over 5. So this is the process that you will follow in order to find the global maximum or minimum of a function in a given interval where the interval is closed and the function is continuous on that closed interval. I hope that this discussion was helpful. Thank you very much.